Okay, in these two questions, we're looking at finding the distance between 2 points. Now, basically, it says find AB, that is find that distance. They've drawn a line between it over here, they haven't, but it makes no difference really. It's still the same way of solving it. So what I'm going to do to find that distance is draw a right-angled triangle. Now, the reason I draw a right-angled triangle is so I can use some Greek bloke's theorem, which is Pythagoras, which you should have heard of. If you haven't, have a look in your revision guide or what have you, or one of the other videos for Pythagoras' theorem. Now, I'm finding the hypotenuse of a right-angled triangle. That's the long side opposite the right angle, and I've got to work out what the two short sides are. Now, that's pretty straightforward because I've gone from 1 up to 4 along here, which is a difference of 3, and from 4 up to 8 here, so that's 4. Now, if you've done Pythagoras, you'll notice that this is actually a nice famous Pythagorean triple where the hypotenuse is 5. But if you don't recognise that, okay, Pythagoras' theorem means you square, or tells you, sorry, to square the two short sides, add them up, and then square root, and you get the long side. So here we go. So we've got 3 squared plus 4 squared. All right, now 3 squared gives you 9. 4 squared gives you 16. They add up to make 25. Okay, and actually, if I put this little question mark here, my question mark is going to be this here. Square root of 25 gives you 5. But this is a nice little Pythagorean triple that some examiners will be expecting you to spot, actually. So there you go. Now the second one, exactly the same sort of thing. I'm actually going to draw a line between it so I can see the triangle, and that's not a very good line, is it? But there you go, there we go. That's slightly better. And I'm going to draw my right-angled triangle in. Now, what you'll notice here is that we've got not a coordinate there, but we've just got a number. So actually, if I'm going to finish that coordinate, that is on the x-axis, so it's gone up nothing. So the actual y-coordinate there is 0. I'm going to do the same thing here, all right, as I did before. And 2 to 6 is 4, and 0 to 4 is also 4. So we've got 4 squared plus 4 squared. Now, what you may notice now is that we get 16 add 16, which is the square root of 32. Now, that is not a square number, 32, but you might be asked in the question, particularly if it's a non-calculator paper, to simplify this or give your answer in surd form or something like that. Now, that again, look it up if you're not sure about that, but what I'm going to do is I find a square number that goes exactly into 32, and 16 is my square number that goes into 32, and it goes in twice. So now I can separate them, sorry, and square root 16 to get 4. So my answer would be 4 root 2 in its simplest surd form.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.